If you put it where the sun is, it would loosen up to the circle of Jupiter, a monster totally shaky and going to explode. They are among the most prominent impacts of radio energy in the entire universe, delivering more energy than a billion suns. Bug Juju, or frightening crawly Jew, is a red Goliath star. If you put it where the sun is, it would connect with the circle of Jupiter, monstrous, completely unpredictable, and also going to explode. When we consider stars, we most likely imagine small glowing things in the night sky. Basically, this is the way we see them from down here on the planet. But stars are something completely different. Actually, one of the most prominent stars, Betelgeuse, is much greater than our sun. For many years, this star has confused analysts. However, recently, something more upsetting has been happening with Bug Juju, making scientists and other very well-educated individuals incredibly concerned. Join us in this video as we explore the marvelous news about Betelgeuse, its approaching obliteration as expected by the James Webb Space Telescope, and how this new discovery will impact our universe and our lives here on Earth. As explained by physicist Michio Kaku, Betelgeuse is a huge marvel, a giant star that has interested cosmologists for a long time. A Greek astronomer named Antonius was the first to find it. This star is so giant that it can be viewed in the night sky from Earth, particularly during winter. If you're into cosmology, you've probably seen or heard of this star. The blushing orange star marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient and is, so far, quite possibly one of the most brilliant stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay consistent. Rather, it varies. This change is one of the great properties of the star, but it isn't the only one. We should investigate some of Betelgeuse's specific properties. The majority of the stars you see in the night sky are far from Earth. The closest star is 4.2 light-years from Earth. In case you fail to perceive how the term light-years gives a sense of distance, picture it this way. Consider moving at the speed of light for an entire year. It's been shown that light can cover a distance of 186,000 miles per second. So, the distance light can cover in a year is comparable to 1 light-year. Crunching the numbers will give you billions of miles. So, when we say the closest star is 4.2 light-years away, it means it is billions of miles from Earth. Anyway, contemplate this. Some stars are much farther, and Bug Juju is one of them. Bug Juju is found about 600 light-years from Earth. So, if you somehow ended up going to it at the speed of light, it would still take 600 years. We can't move that quickly, not even our fastest space rockets can. Yet, this star can still shine so brilliantly in our sky. If you're wondering how Betelgeuse can be so bright regardless of its distance, that's due to its unique qualities, like size and brilliance. Betelgeuse is multiple times greater than our sun. Its radius is acknowledged to be on different occasions that of the sun. Tragically, it appears as a disk in space when using modern telescopes, while various stars appear as small points of light. This is thought to be an effect of the reactions at the outer layers of its atmosphere. When it comes to mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by space experts. One solar mass is equivalent to 2 by 10 to the power of 30 kilograms. Scientists can't determine the specific mass of Betelgeuse since there are no other planetary bodies orbiting around it to compare it with, and obviously we can't measure it directly from here on Earth. However, this makes Betelgeuse, at least on different occasions, heavier than our sun. The brightness of Betelgeuse goes from magnitude +0 to +1.6. In more familiar terms, Betelgeuse is on many occasions more brilliant than our sun. No wonder it was nicknamed a red Goliath. However, the brightness of Betelgeuse doesn't stay consistent. It fluctuates. This change is due to its pulsations. In other words, Betelgeuse grows and contracts. When it expands, it gets brighter. When it contracts, it dims. This cycle can endure for 10 to 100 days or even much longer. A novel property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is much stronger than at the typical surface. However, the downside is that these strong magnetic spots frustrate the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has so many of these spots compared to our sun makes sense of why it is cooler than our sun, regardless of its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and significantly more numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is on different occasions stronger than that of the Sun. This field is the reason that when seen through a telescope, the gases on the outer layer of Betelgeuse appear to be in circles or curves. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the low energy radiated by the star and its weak red tone. Betelgeuse is a red star, but it wasn't always red. It was yellowish around 10 million years ago, much like our Sun. Over time, the color began changing to orange-red, and then around 100,000 years ago, it slowly started transforming into the red star we know today. This fact has led scientists to believe that the star is maturing. Betelgeuse produces as much as 100,000 times more energy than the Sun. It would have been a fierce contender to Earth's Sun if it weren't so far away. The fact that Betelgeuse, which is 600 light-years away, can still be seen with the naked eye at night is extremely striking. Our Sun is only 8.3 light-minutes from Earth, and that's why it's so strong. If Betelgeuse were just somewhat closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would consume or displace the Earth and the other 4 planets near it because of its gigantic size. Besides, regardless of whether it were to match the Sun in size, it would still discharge more radiation. Betelgeuse, also known as Bug Juju, is a very giant star located in the constellation Orion, about 600 light-years from Earth. Its gigantic size is one of its most striking components. It is multiple times greater than our Sun in terms of radius and could easily incorporate the circle of Jupiter if placed at the center of our solar system. This legendary size allows Betelgeuse to appear as a disk instead of a point of light when viewed through powerful telescopes, in contrast to most other stars. Despite its gigantic size, Betelgeuse isn't the most enormous star. Its mass ranges from around 12 to 19 times that of the Sun. This variation in mass estimates is due to the challenges in precisely measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. Indeed, even at its lower estimated mass, Betelgeuse remains a huge celestial body. The brightness of Betelgeuse is another key characteristic. It fluctuates consistently over time, with its brightness going from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can ultimately be up to 1,000 times more brilliant than our Sun. This fluctuation is ascribed to its pulsations, intermittent expansions and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for months, adding to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct red color, typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It displays dark magnetic spots on its surface, where the magnetic field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a massive, vigorous star, but it will eventually meet its end in a spectacular supernova. Betelgeuse is an enormous star approaching the end of its life, and its possible fate will be a dramatic one. When it runs out of fuel, it will undergo an extreme process of fusion, turning heavier elements like helium and carbon. This will cause the star to expand to possibly much greater sizes, making it one of the largest stars in the night sky before it dies in a cosmic explosion. A catastrophic blast that marks the death of a massive star. The power of a supernova is strong enough to briefly outshine an entire galaxy. This phenomenon could potentially send shock waves through space, and it's possible Betelgeuse will end its life in just a few million years. This would be an astronomical blink of the eye considering the millions of years it took for Betelgeuse to become the star we observe today. The possibility of Betelgeuse becoming a supernova has intrigued astronomers for centuries. New research, particularly from the James Webb Space Telescope, has accelerated understanding of this process, revealing new data about the star's behavior. As a red giant, Betelgeuse's future as a supernova is nearly inevitable, and the aftermath of that event will affect the surrounding space and possibly our solar system in ways we cannot yet fully predict. Betelgeuse, also known as Betelgeuse, is part of the class of stars known as red supergiants. These stars are the final phase of stellar evolution for massive stars that have exhausted their nuclear fuel and are preparing for a dramatic end. Unlike smaller stars like our Sun, which will eventually shed their outer layers and become white dwarfs, red supergiants like Betelgeuse have a different fate. They will explode in a supernova, an event so energetic it can outshine an entire galaxy for a short time. The evolutionary path of a star like Betelgeuse begins when it forms from a cloud of gas and dust. Over millions of years, the star undergoes nuclear fusion in its core, converting hydrogen into helium and releasing vast amounts of energy. As the hydrogen in its core is exhausted, the core contracts and the outer layers expand, leading to the star's transformation into a red giant, or, in the case of Betelgeuse, a supergiant. In this phase, the star begins to burn heavier elements, such as helium, carbon, and oxygen, in its core. The fusion of these elements releases more energy, causing the star to expand even further and cool, which gives it its characteristic red color. Betelgeuse's sheer size and mass make it one of the most well-studied stars in the night sky. It is a variable star, which means its brightness changes over time. These fluctuations are caused by its pulsations, where the star's outer layers expand and contract. As Betelgeuse pulsates, it causes a periodic dimming and brightening, making it one of the most interesting stars to observe. These pulsations are believed to be related to the star's instability, a common characteristic of stars at the end of their life cycles. Scientists have been able to track these changes in brightness, helping them learn more about the star's internal processes and its eventual fate. Despite its size and brightness, Betelgeuse is not the largest star known to humanity. There are other stars that are even more massive, like UY Scuti, a red supergiant that holds the title for the largest known star in terms of volume. However, Betelgeuse's location and variability make it a particularly valuable subject of study. Its relatively close distance to Earth, about 600 light-years, allows astronomers to study it in greater detail than many other stars. Through observations from various space telescopes, including the Hubble Space Telescope and the recently launched James Webb Space Telescope, astronomers have been able to learn more about Betelgeuse's structure, magnetic fields, and the ways in which it is shedding material into space. One of the most exciting discoveries made by scientists in recent years is the possibility that Betelgeuse is closer to the end of its life than previously thought. While it was once believed that the star still had millions of years before going supernova, more recent data suggests that it could be only thousands of years away from this catastrophic event. This timeline is much shorter than previously expected, which has intrigued astronomers and sparked further studies into its behavior. The most recent observations have shown that Betelgeuse's outer layers are beginning to eject large amounts of gas and dust, a process known as mass loss. This mass loss is typical of stars nearing the end of their lives, as they expel material that they no longer need for fusion. This process is not only important for understanding Betelgeuse's future, but also for the broader understanding of how stars evolve and die. When Betelgeuse eventually explodes in a supernova, it will release a tremendous amount of energy, along with heavy elements like iron, nickel, and calcium. These elements will spread throughout the surrounding space, enriching the interstellar medium and providing the raw materials for the formation of new stars, planets, and potentially even life. In this sense, the death of Betelgeuse will not be an end, but a beginning for future generations of stars and planets. In addition to the physical processes happening within Betelgeuse, its death will also have significant consequences for its surroundings. The shock wave from the supernova will send high-energy particles and radiation across vast distances. This burst of energy could have an impact on nearby stars, planets, and even the interstellar environment. If Betelgeuse were closer to our solar system, the radiation from its supernova could potentially affect Earth's atmosphere. However, because Betelgeuse is so far away, this will not pose a threat to us directly. The study of Betelgeuse also provides insights into other red supergiants and their place in the cosmic life cycle. Stars like Betelgeuse are critical for understanding the late stages of stellar evolution. These stars are some of the most massive and luminous objects in the universe, and studying them helps scientists understand how stars evolve over billions of years and how the elements that make up our universe are created. For example, the elements that form our planet and everything on it were likely forged in the cores of ancient stars that exploded as supernovae long before our sun was born. Overall, the life and impending death of Betelgeuse serve as a reminder of the dynamic and ever-changing nature of the cosmos. From its fiery birth to its eventual explosive end, Betelgeuse's journey through space and time offers a glimpse into the incredible processes that shape the universe.